on improving how we baseline embodied carbon, which is going to be a facilitated technical discussion. This is pretty exciting. I mean, if you've been to our previous events, you'll know that oftentimes our events are typically, on a specific topic. We'll invite some experts to give presentations, and we have some time for Q&A at the end. This time around is going to be a little bit different. We're going to actually focus on really making the most out of the time that we have with you and actually getting your input and your feedback to this really interesting and important topic. Oops, let me just get started. So to give you a quick overview of the event, the intention tonight is to actually gather feedback from all of you and to facilitate a discussion around how we can improve how we define baselines in whole building life cycle assessments. And sometimes you'll hear me kind of using whole building life cycle assessments interchangeably with embodied carbon. LCA is life cycle assessment is what we use to quantify embodied carbon. And so that's really what we're talking about. In the context of looking at a whole building, how do we define the baseline building versus whatever we're actually designing in our proposed building, and how do we determine that percentage reduction in embodied carbon? And so that's going to be what we're talking about tonight, is baseline definition for buildings from an embodied carbon standpoint. Now, this event will be recorded, so it will be recorded and uploaded onto our CLF YouTube channel afterwards. I know a few people were asking about this, especially for obviously the people that aren't able to join tonight. Another thing that you should be aware of is that because one of the intentions of tonight is to gather your written feedback, and we're going to be capturing that through Google Docs and also a tool called Mentimeter. We're going to be capturing all that feedback and also making that publicly available. Now, whatever you type in tonight, it will be anonymized, so it won't be kind of attributed back to you. But I just want you to know that those comments will be shared publicly. And part of the reason of that is because I think this is a topic that a lot of people have quite a bit of interest in, and they're wondering, what are the different perspectives that different people within the industry have on this topic. And obviously, this will be important in the context of regulatory regulations relating to embodied carbon. So for example, the City of Vancouver has an embodied carbon target or a policy where it's targeting a 40% reduction in embodied carbon by 2030 relative to a 2018 baseline. And so, the City of Vancouver will look at this set of outputs, but I'm sure, other people, whether you're an LCA practitioner or you're somebody that's part of a green building certification program, or you're developing policy, I think a lot of people are going to be interested in this type of written feedback. And so, yeah, just to let you know that this will be shared publicly and anonymized. Now, a quick overview of the schedule. We just have 1 hour together, so we want to make the most out of this. So I'm going to give a quick intro presentation to sort of just set the frame around the topic and also go over the logistics of tonight. And then we're actually going to jump into breakout rooms. So all of you will be split up into different breakout rooms. And then from there, you're actually going to have an opportunity to type in some of your feedback to 2 questions that are on a Google Doc. And so everybody within your breakout room will be using the same Google Doc. You'll kind of type in some answers to questions. And then from there, you can have a good discussion, about 15-minute discussion amongst all the people in the breakout room. Afterwards, we're going to bring everyone back together into the same room. So everyone all into one big group discussion. And throughout that time, I'll also occasionally ask some questions of the whole group. And then you'll be able to use a link to a tool called Mentimeter to type in your answers to some of those questions as well. Now, the formal part of this event is 1 hour long. However, for those of you that do want to stick around afterwards, we will be keeping the call open for another 30 minutes. And that's kind of an optional post-event discussion. But the formal part where we're collecting feedback is going to be in the first hour. And one thing to note is that the links to the Google Docs and also to the Mentimeter will be live even after the event. And so if there's any feedback that you wanted to kind of capture but weren't able to write it down during this event, you can come back to it within the next, 24 hours to kind of type in whatever was missed there. Okay, so broadly speaking, we're talking about baselines tonight. Now, when we're thinking about embodied carbon, oftentimes the topic comes up between baseline versus benchmarks. And so when we're talking about baselines, that's really something that's derived from a single building that may come from either a theoretical design or perhaps even a already fully constructed design. And oftentimes these baselines are what we use to define a certain percentage reduction target, to define how much reduction in embodied carbon we achieved. It's relative to a kind of a baseline building. So that's the approach that, for example, LEED through the Material Resource Credit One uses, or the International Living Futures Institute uses this. Also the CaGBC Zero Carbon Building Standard. So that's kind of the baseline approach, where you have one building. It might be the same building, but just designed with different kind of alternative design options or assemblies. You use that as the baseline, and then you have a kind of a percentage reduction relative to that baseline. We also have what's called benchmarks. And so benchmarks are based off of, they're a statistically derived datum from a sample set of construction buildings. So let's say you have a set of 500 buildings or 1,000 buildings or however many buildings. You can kind of look across the range of all of those buildings and determine certain benchmarks. And oftentimes these are used in an absolute context. So looking at, for example, kilograms of CO2 per meter squared of floor area. And you could potentially use these types of benchmarks to, for example, set a maximum limit. So like, maybe all projects need to be below 500 kilograms of CO2 per meter squared. That's kind of another approach. So in terms of the benchmarks, these are some examples of benchmarks that exist out there. In 2017, the Carbon Leadership Forum had a benchmark study where they looked at over 1,000 buildings around the world. They kind of looked through these different whole building LCA studies, and they kind of gave ranges. And as you can see, there's a very big spread between the low end and the high end. It could be below 100 kilograms of CO2 per meter squared all the way to over 1,000. And there's a lot of things that can influence these benchmarks. So for example, what software tool are you using? What are the different types of buildings that you're including in that data set? Are they comparable? Are they completely different archetypes? Do they have underground parquet? Do they not? So there's many factors that can influence this. And obviously the structural frame, is it a concrete frame, steel frame, wood framed, etc. So this can lead to some of the differences there. One-Click LCA also is a software tool. They also have a benchmark, so they kind of create letter grade ratings. So this is sort of the benchmark approach. But for tonight, what we're talking about is mainly the baseline approach. So where we're defining a certain percentage reduction relative to a baseline. And so there are different approaches to doing this. Some people use an early design iteration. Some people use an alternative design, which personally I think is probably the most robust way of doing this. So basically you design the exact same building that you have, but you just kind of swap out, the different material design decisions or assemblies to define the baseline. You could potentially compare this against an existing building that is functionally equivalent, or you can look at different building archetypes. So it's sort of a theoretical typical building. Now that's a very, very high level overview, but with that, the intention today is not so much to kind of go through a presentation, but really to get your thoughts on this topic. Now, I want to emphasize that, there's going to be people with many different levels of expertise on this call. Some of you have done LCAs and have a lot of opinions about how to do this or what's missing and what type of, what are the challenges there. And some of you may not have too much experience in this. So, in terms of the written feedback that we're gathering here, what we're looking for is quality feedback. We're not necessarily looking for as much quantity or as much feedback that we can capture. So for example, if there's a certain topic that you don't have a particular opinion about or thought about, don't feel like you need to write in a response in there. But vice versa, like if there is something that you think definitely should be added to the conversation, definitely write those in as well. So in this breakout room, what we're going to do is we're going to start off, it's going to be 20 minutes long. We'll start off with 5 minutes of silent writing time. So please just don't do introductions to everyone. Just actually type in your name and company/organization, and then start looking at those first 2 questions and try to use that 5 minutes to just type out whatever responses that you have in there. And if you're finished, then you can take a look at what other people have written there. And for example, if what other people have written particularly resonates with you, you can add an asterisk or a little star at the beginning of that line or in the front of that line. And so this will be kind of a way of getting a sense of which points are being raised within that breakout room that are particularly resonant. After you've spent 5 minutes, we will send a broadcast message out to everyone that says that the 5 minutes is up. And then so from there, then you can actually verbally get into a group discussion and maybe just prioritize the points that have the most asterisk points first. Maybe get the person that wrote that line to kind of give some comments, and people can kind of respond to that. You can let the conversation be quite organic and flowing, but this is just a way of allowing everyone to just give some thought to the questions first before jumping straight into the discussion. So you'll have 15 minutes to discuss, and then afterwards we'll close the breakout room and bring everyone back in. We will be sharing a link. Actually, Jeremy, can you share? Well, I hope that was a good discussion for everyone. What we're going to do next is actually use this thing called Mentimeter. So I'm going to share this link in the chat. So please, everyone, just click on this link that's in the chat. That'll open up a new tab, which is for this thing called Mentimeter. Now, within that, essentially what it does is I can basically show a question, and then you can just type in a freeform response to it. So, oops, sorry, that was my alarm. It's very zen like an alarm. I guess the first question is, what was your key takeaway from the breakout room? Was there something that stood out for you in that discussion? So please type in whatever stood out for you, and then as the responses filter in, it'll pop up in here. Variety of levels of experience. Yes, there's definitely a big difference in experience level in this. It's a relatively new topic for a lot of people. We have a comment on guidelines and consistency is desired and needed. That's good. We're not at all different we're all at different stages of understanding. It's complicated. Material availability for typical buildings, guidelines for EPDs and procedures. What do we do about parking? Industry standard for data to use. More comments for consistent deadline. That was too quick to discuss a very complex topic. I totally get that. And some people didn't get an opportunity to speak. Yes. Yeah, well, we will have more time as a group to discuss as well. So especially if you can stick around, hopefully. We need more embodied carbon and material quantity data for buildings, more LCAs split by archetype, by assembly, superstructure, foundation, enclosure. Close my window. There's a big difference between specific EPDs versus the industry average EPDs. Let's see, more research and investigation needed. Thanks for sharing a lot of the responses here. There's a lot of confusion. What I'm actually going to do now is, so I'm going to scroll through this for a little bit longer just to show some of the different points that are being raised. And then I'm actually just going to invite you to raise your hand if you want to speak. And so at this point, we're just going to have some sort of popcorn sharing. So please, given the number of people on the line, keep your responses to relatively like a minute or so or less. But yeah, we just want to get a bit of a discussion as a whole group going. So what are some of the key topics that you see really needs to get addressed in these guidelines and in how we define baselines? So does anybody, actually, I'll leave it to Jeremy to manage this, but if you want to raise your hand, the way you do it is there should be a little reaction icon. And if you click on that, there's an ability to kind of raise your hand. So you can raise and lower your hand, and that's how we'll prioritize who to speak. So I think, Martine, if you can unmute yourself. Yeah,
more data so we can figure out what we don't know. As many ideas as we can come up with now, there's a lot that we might not be considering.
And what type of data do you mean by that? Or what type of data would help?
In embodied carbon data, material quantity data, making sure just to overcome the what if you're using different LCI data, but more information about what do buildings look like, and then information on the typology and whatever. And this is being done by stuff like SE 2050, but just keep doing it in more projects and more information.
Totally. Okay, that's perfect. Anyone else have any comments or even to respond to that? Rob?
Yeah, using a 2018 baseline is at a time when we have peak parking, at least in the city of Vancouver. We have a lot of parking being built in the last 10 years. And it's a very artificially high baseline to be comparing ourselves to the future, when I think that we should maybe go back in time before we provided so much parking within our buildings to say another time, such as 1955.
No, that's a good point. And I think parking is definitely one of the big aspects and considerations. And I think this gets to the point also about like, what does 2018 baseline mean? And is it just like what's common practice at that point? And especially in the context of if we're thinking about what I presented earlier about baselines versus benchmarks, are we trying to look at a sample of buildings and then trying to come up with kind of what are averages or benchmarks from there? Or are we looking at just for this given building that you're designing right now, creating a baseline specific to that case, in which case maybe the parking is the same or maybe it's different. Yeah.
In Vancouver, if you take a sample, most of the buildings have a huge amount of parking being built right now. You take, and so if you go back to 1955, very few buildings have parking. So, and you could take a sample in both cases. So,
yeah, no, that's a good point.
Okay.
Does anybody have a response to that, or perhaps another comment?
I was going to say that's one approach, and it sounds like what Rob may be insinuating is that it's sort of artificially high, and it's easy to actually get better than that, even with policy changes to parking. But maybe another way to address that is maybe be a bit more aggressive with the % better than targets related to 2018. You know, to compensate for the fact that policy may be already veering away from excessive parking, if you want to call it that. I'm not sure. Maybe that's another approach.
Yeah, that's a good point. Anyone else? Oh, Matt?
Yeah, the way I think about baselines is more along the lines of how it's structured in LEED, in that the baseline is an imaginary building that is never going to be built that offers the same functionality as the building that is being built at the time that it's being built. So the baseline as far as 2018, that is not, I don't see that as a baseline that you're comparing a building to. It's the baseline that the city has set to say, overall, this is where we need to be. This is our starting point. This is our peg in the ground that we need to be reducing from, and that's where we come down from.
Yeah, that's a great point. Maybe Patrick can speak about this, and then we'll go to Jason afterwards.
Hey, yeah, I was thinking just, having spent a lot of time on baselines in my energy modeling days, I think something that comes to mind for me is just like, what are all the things I can take credit for versus the things I can't? Like if I'm using materials more efficiently, or say building less parking, is that something I can take credit for or can't take credit for? If I'm building a mass timber building, can I take credit for that compared to a concrete building, or just compared to another mass timber building? Like, to me, these are, the question of like, what can I take credit for in a baseline approach or in a comparative approach is a really important question.
Totally, thanks for that. Jason?
Yeah, I think I was just going to kind of build on the same concept of like, if we're reducing parking in a building, is our baseline assuming the same amount of parking, and we're just looking at especially because we're considering like an LCA, are we just looking at the materiality of that parking structure and any reductions we get, or are we looking like, hey, I made a conscious design decision to build 50 less parking stalls. And so I should get a credit for that. And then that's where I think, a little bit of like drawing from the energy model kind of approach, where you have a baseline that's a little bit prescriptive in terms of saying like, these are your plug loads. And if you're not doing anything amazing, then your baseline and proposed have to be the same. So just an idea.
Perfect, thank you. Elizabeth?
Yeah, personally, I feel like that it shouldn't be too long until we move away from baselines and move towards absolute values, so the same as EUI and TEDI numbers. And I know the data is maybe not quite there at the moment, but I think soon it will be. And so I think that will be, especially for embodied carbon, the way to go, like a per square footage kind of amount, because I just think that the comparative aspect is so, no matter how many guidelines we put, it's still going to be so subjective.
Yep, I got that. Thanks. Veronica?
Hi, I was just going to say the same thing about having fixed performance targets in the same vein as, or in a parallel way as the energy use intensity and TEDI. It might be, how do you say, easier or more stringent approach. There might be a reason as to why the energy targets might have moved from a percentage reduction to a fixed performance.
Yeah, thanks for sharing that. Sharzad?
Seems like we're on a bit of a roll here, but I was gonna actually raise the same thing. I think we've got a bit of a ways to get there, but moving towards more performance-based and absolute targets, I think would be ultimately where we want to sort of go to eliminate the subjectivity of defining a baseline. I think we have the data to assign, let's say, targets to certain different types of buildings, and then striving to achieve those targets and sort of taking inspiration from the step code, I think would be sort of the way forward.
Yeah. And maybe I could just add a quick point on that front, just because I know this is a common point that typically comes up, and I don't know that there's a right answer per se, but just maybe as a counterpoint for why you might potentially, or what are some challenges that might come up from that standpoint, is the different LCA software tools use different underlying data and assumptions, so that can lead to some of the differences in the absolute numbers that you actually get to. Also, like what's actually included in the scope of your analysis, as you actually include more and more scope, you know, for example, like structure, envelope, and then now you start looking at interiors, or you look at MEP systems, that number progressively gets higher as well. So then that becomes a bit of a challenge. If you set that target too high, that absolute number, like let's say it's a limit, it needs to be a certain level, it doesn't really serve much purpose potentially because it's too high. So it's not actually changing your design. If it's too low, maybe it actually addresses some other factor that there's maybe some unintended consequences that's specific to your building form or your typology. So I think not that it can't be done, it could definitely be done, but I think there's just a lot of factors that need to be considered on that front. And also, as you get from early design to later stage design, oftentimes the trend is that the embodied carbon gets higher because the material quantities that you're accounting for are higher over time. So that's another factor. So, you know, maybe like with a baseline approach, having a reference building, it could potentially hold a lot of other variables constant and really look at what is the actual intentional design decisions that you're making that lead to some sort of reduction. But yeah, anyways, that's a certain point. Yuri?
Yeah, can you hear me well?
Yep.
Okay, yeah, so something we're puzzled internally in our company when we talk about baselines, we kind of see two types of baselines. One baseline is you use an analysis today for a specific building. And I guess we have flexibility here. As we're getting better, as we progress, that baseline, we're gonna get better as well, right? And we're like competing with this baseline, and this is how we get better and better. And if we assume something that is maybe not incorrect or not perfect, it's okay. We can adjust it as we go, as we learn. As you mentioned, there are other things will be considered. Then, and I guess we've been concentrating our conversation on that. What we're puzzled about is like, okay, well, but then as we were thinking about committing to a 40% reduction, 50% reduction, against what? Like we have to have a baseline that we're gonna assume right now, and it's not gonna change. That 10 years, 5 years from now, we're gonna come back and we're gonna say, so. But as we're establishing this baseline, the industry already getting quite better. Like I can see over the last year, a lot of the stuff getting quite better. And whatever baseline a year ago, it's not what's baseline today. And yeah, I'm curious if when people say we commit, what's generally the baseline? What's the
That's the $1 million question here. That's good. Actually, this is a good feed into the next. So I want to show you something that's sort of like an early draft of what the City of Vancouver is potentially looking at. And then I'm going to throw up another Mentimeter slides where you can actually provide some feedback on this. So I'd be very curious to get your feedback on this. So let's see. So I'm going to share my screen. So this is one potential way of doing this. Now, I'd be curious to get your feedback on both the actual just the overall approach of this, whether or not this is kind of the right type of approach, and maybe having some specific comments on the individual elements in here as well. So for example, one way we could actually provide some guidance on this front is for a certain building archetype, for example, low-rise residential or high-rise residential, we specify some baseline assumptions, potentially even down to like what type of concrete mix you use, like to use the industry average benchmark mix from the Canadian Ready Mix Concrete Association, or could you maybe even find something that's a mix that's perhaps more reflective of what's the local average? So for example, maybe if Portland limestone cement, GUL is a common mix, we could potentially use that as a baseline. So these are just kind of working ideas around this. Could we, for example, define what is the typical exterior wall or the typical insulation that's used or the typical roofing that's used or the glazing? So if you go to the Mentimeter link, going back to the link that was shared in the chat earlier, we're actually going to be moving into, I believe it should show the next question, which is, do you have any comments or suggestions relating to the draft list of baseline material assumptions? So whether it's commenting on individual items in here or just the general overall approach. So that's the question. If you go to the Mentimeter, you can kind of go and start typing in the answers. I'll leave this up for reference. So I'd be very curious to get people's feedback on this. Like, should we actually have this level of guidance? Would it make sense to be able to define this level of guidance, like down to like what type of assumptions to be used by material? Do we need more granularity on this, for example? Like, do we need to kind of isolate this down to like more different building archetypes? Do we need to have more granularity on like the type of assemblies that we're defining, et cetera? So any comments that you have on that, please share that on the Mentimeter link right now.
I think the one on the left, is 7 up to 7, and the one on the right would be, say, 7+ residential.
Oh, right. Yeah, sorry. Sorry. Less than 7, so like 6 stories and under. For the low rise versus high rise is 7+. That was a typo. So as we're, I see that there's a request to send the Mentimeter link again. Jeremy, can you just send the Mentimeter link again onto the chat?
Yep. Yep. 1 second.
Yeah. All right. And we'll just give that a second, and maybe in like 2 minutes, I'll actually shift over and actually see what type of responses are coming through. Let me just see if there's, okay, good. There are some responses coming in. If you need, you could potentially take a screenshot of this if you want to just look. And mind you, this is a very early draft. This is not like kind of the finalized list or whatever, but any feedback is welcome on this front. So if you need, please take a screenshot of this, because I'm going to move over to the Mentimeter link now. All right. So we have lots of responses here. So that's great. Let's see. I guess I need to press pause. This is actually kind of hard to read. Let me see if I can make this a bit smaller. Sorry about this. There's my cursor. Sorry, for some reason my cursor is gone. Let me see where it went. Present. Okay, could be overly simplistic. What about MEP or similar approach? Less common archetypes will be needed or need to have guidance. We need to define for MERBs, office, et cetera, very prescriptive for engineers. Window to wall ratio is going to impact the outcome. So that needs to be taken into account. How do EPDs playing into this? There's so much variability. I like the general approach, overall approach. It's the only way to get consistency and a starting point on percentage reduction. Are you proposing this for Vancouver or what region? Yeah, in this context, it is specific to Vancouver. But yeah, potentially a similar approach could be used in other jurisdictions. Let's see, this may be too granular to compare whole buildings, but separating by assemblies would be useful. Glazing ratio is difficult. How do you balance embodied impacts versus operational energy trade-offs? For embodied carbon baseline purposes, won't be comparing, oh, that moved too quickly for me. Let's see, there should be different versions. Okay, so with that, there's many comments on here. I'm actually just gonna open it up now for discussion. So please, raise your hand. And if you, after you've spoken, please do lower your hand, just so we can kind of keep track of which people want to speak next. But anybody want to comment on this? Or sure?
I'll just call out Eric. I know his hand wasn't working. Eric, do you want to contribute to this?
Oh, not at the moment. Thanks.
Okay, great. Any thoughts, or anyone want to just expand on the point that they wrote down on here, for example? Oh, we have some more. Okay, so Martine.
Are you considering that you would, like, if comparing buildings that apply, that for which all of these criteria apply for each assembly? Like we're only going to compare residential buildings under 7 stories that are this strength concrete, this SCM replacement, for the whole, like, check all the boxes, or just?
I think perhaps the idea would be, for example, if you have the proposed building that you're modeling, you actually create an alternative version of that uses these as the assumptions for that baseline. So like these assemblies or these materials in that alternative design. And so then then your building is still functionally equivalent, but you're using kind of what are considered maybe the typical materials or assemblies that are used for.
I see. So like a standard practice. Yeah.
In a way, yeah. But the takeoffs for the building and the massing and everything is still the same, because you're actually modeling the same building, but just using different assumptions for the materials or the base. Is one possible interpretation, but that's what I'm kind of thinking on that.
Yeah, because I mean the comments that I've seen about, like, oh, this will always favor wood. It's like, well, is that a bad thing? But I think doing something like this alongside leveraging the work that's being done for establishing material baselines. Mm-hmm. I think that's much more simple, just because necessarily more simple. You're comparing the same material. Yeah. Having those work in tandem with one another, I think is a great approach. I think it's well done, well thought through.
Yeah, so this could actually, maybe those specific line items is actually referencing, for example, what CLF has created for their material baselines. They actually have average, baseline numbers for individual materials. So perhaps that could actually reference that, but in the context of, okay, but which material do you select for what element within a building?
I see. Yeah. That's cool.
Awesome, great, thanks. Roberto?
This is a really challenging exercise. Yes. I can see why Patrick might be losing his mind at the city there. I only looked at low rise, and I guess my comment was like, that's an archetype. Those assumptions there are kind of like, they fit a specific archetype. So somebody, I think somewhere at one of these boards had actually mentioned, by archetype. So maybe there's a value in defining the archetype. The archetype's going to change though. Like, the archetype of today, like I'm thinking of interior stud walls. Yes, some are steel stud, but we're seeing, more and more wood going up in low-rise buildings. So maybe for certain types of archetypes, it makes sense, and others it doesn't. So, it's sort of one way to base your assumptions on an archetype. So if it's a flat roof building, 3 stories, this kind of window wall ratio or something, it defines it as the archetype, and then you go dig into those sets of assumptions. I don't know. It's challenging.
It is. That's why we're having a discussion about it. We're not presenting answers. I think, is Penny Martin still on the call? I think she had her hand up.
Hi, yes. Thank
you.
I just wanted to comment a little bit more about wood. And I can see there's a lot of discussion about all the details of the baseline, but this looks like it really will favor wood in a really big way, especially the low-rise archetype, which could often be built-in wood. But
I think maybe you cut off.
I think we lost Penny's audio.
Oh, okay.
It's all wood people who.
Yeah, but I think that's a good point. Maybe we actually need a different, maybe more granularity on the archetype, and maybe it's 3-story and below. Like maybe that's a wood frame building instead of a concrete. So yeah, maybe we need more granularity on that front. I'm not sure if that's where she was going with that, but Penny, okay, If your audio does come back on, feel free to mute. Elizabeth.
I think it's I like the idea in general. I think one thing that seems to be highlighted to me is that it doesn't, it's mostly focused on material choices as opposed to design kind of alterations. you know,
Yes.
like reducing total amounts of concrete rather than kind of using a different material of concrete, which is, we're noticing in our firm that can be some pretty big savings.
Well, I wonder if could they be compatible? So like maybe this is just the assumption for what to define the material to be, but you could still potentially account for savings that you have in, I don't know, if you change your structural grid or something and you've managed a way of like saving the amount of concrete or reducing the concrete volume, you could still.
Right, so there's like, these are the kind of material
maybe these are just
things for the base design, but then there's still stages of base design where the actual design kind of transforms over time as well. Yeah,
potentially, yeah, and maybe maybe we need to provide more guidance. Maybe it's not just the materials. Maybe it's like it needs to be a, I don't know, a 30 by 30 grid or something for this type of archetype. And
no, I don't think necessarily. I think, but just having that kind of made clear as it could also incorporate the design would be, yeah, it's a good point to make. But I don't think, yeah, it made it absolutely good.
Perfect. Actually, I just realized we're hitting 6 o'clock right now, so. For those of you that do need to jump off the call, thank you very much for joining us. We're going to keep the line open for another half hour, so I think this will be a pretty lively conversation. So I definitely, invite you to stick around if you can. But if not, thank you very much for joining, and we'll email the recording and also these outputs to everyone after the fact as well. So we'll look forward to that in your inboxes. But if you need to leave, please feel free to leave. But we're just going to keep going with this, and I'm actually just going to unshare my screen so we can actually see each other's faces, because that's probably better. All right, Rob.
Talking about archetypes, that seems to be something that's very fluid right now. We're looking at all sorts of different building technologies, building typologies, and as I've mentioned before, with the parking maximums proposed by the City of Vancouver, we're looking at buildings with a lot less parking, especially along the Broadway corridor. And we're also looking at different materials. I don't know, I'm not an engineer, but there's other materials that are coming into play, certainly in houses, single family houses, such as hempcrete and biochar. And so those things, I don't know if those are materials that could come into play in future building multi-story building typologies. So maybe somebody has some thoughts about that.
Mm-hmm. And mind you, this is just, even that list of material definitions, that's more just for what you define for the baseline. But what you do in the proposed, like, of course, if you're using cutting edge materials, like using hempcrete or whatever, and that helps reduce the emissions, all the better, right? But you just need something to compare against.
Yeah.
But yeah, no, that's a great point. Thanks. Ivan?
Yeah, I think with this approach where you're using a baseline material, there may be some cases where you want to have a bit more granularity and get more specific. So I'm thinking about in terms of structural. If you were to use a more efficient structural system where you can use larger spans, reduce the number of columns, that type of stuff, you want that to be reflected into your design, because that's the design intent. So there should perhaps also, as part of your archetype, you have to define some sort of basic structural design or assumptions in there.
Mm-hmm. I guess, maybe the structural engineers on the call, any input on that? Like, what is there perhaps beyond just the material definitions, is there some way we could potentially define the baseline assumptions around the structural frame? I'm thinking Yuri or anyone else.
Technically speaking, you could. Practically, it never hasn't been happening too much right now. Most of the time it's not needed for getting the results that you're looking for LCAs. It's a task if you are to reframe it, and it's most of the time not part of the budget. So answering your question, it's not happening. It's really what you said before. It's taking the same structure, same building, and using different materials. And this is where we are right now as an industry. It's like, we understand it's easy. We can, one of the project we had to help out LCA specialists. So we took our current structure, we quickly mark up what it would be if we were to do it, typically. Looking at this as a different framing system, you know, brace frame versus moment frame, that's very good too. If it's a part of the scope, but yeah, to be honest, it hasn't been happening much.
The
But it
structural
could be.
engineers need more money is what you're saying.
I think it's structural engineers. It's like overall, you know, LCA consultant get hired on the job and get thrown all these questions, and every single consultant need to come in order to make this real decision, right? What would be the base building structure? Like none of us know all of that. It's all of the consultants that can contribute to define that baseline.
Yeah. And I think the structural aspect is probably one of the most difficult aspect of this. If you're going to take the same building, but create a different, an alternative design, you know, on the envelope side, maybe that's more straightforward. Maybe on, or if you're keeping the same structural frame, but you're just changing concrete mixes, that's obviously like relatively more straightforward too. But if you're comparing mass timber versus concrete or versus a steel frame, that can be a lot more challenging. And yeah, I can get that input. Luke?
Next was Elizabeth.
Oh, sorry. Yeah. Elizabeth?
Oh, sorry. This is kind of a slightly different question, but I was just wondering, have you put these baseline materials suggestions into the different softwares and seen how similar the kind of numbers are for that?
No. And right now, this is a very early stage list.
Yeah, for sure.
Yeah,
totally.
I think this is more just as a starting point on the disc. Like, do we even think this is the right approach?
Yeah, totally. Because I think one of the things would be like, okay, it's kind of nice, potentially good if we go down this line to have a kind of set of material choices. But would we then go in next step and say like, and these are the kind of global warming potential numbers associated with those? Do you know what I mean? Or is it like, and then we're going to you know, kind of allow the different options from the softwares, if that makes sense?
That does, Elizabeth. And if you haven't seen it, I would really encourage you to check out when Zebex publishes it, the recording of our last event.
Oh, sorry, I couldn't attend.
No. It'll be there, and it will be exactly investigating that. Right, okay. Which we know is also a huge piece of it. So I think you're right on.
Yeah, and so I think that's just like a decision to be made. It's like, do you kind of, if we're kind of, you know, recommending a baseline, then are you also recommending a kind of, you know, the life cycle analysis and numbers to go with it, or is it just the materials that are then going to go into the whichever software? So.
Yeah, my initial thought on that is potentially not, because like there's different assumptions underlying those tools, and ideally we're referencing the industry average numbers, so it should actually be still relatively in the same ballpark.
Yeah, relatively similar. Yeah, which is why I thought maybe if we tested it, maybe they're not so different that it has to be an issue. Yeah.
Yeah, probably, but I think the thing that Jeremy is referencing is specifically about like the XPS installation, which is a separate topic.
Right. Yeah.
But yeah, Luke, you have a comment?
Thanks, Anthony. Yeah, so I was just going to speak to the structural bit a little bit too. One point that I want to bring up is I think the challenges in the past with setting a benchmark have been really reaching that functional equivalence, because there's so much variability. And a lot of these assumptions that we're talking about, like using the same database, same scope, these seem like things that we'd want to, you know, if you have the data, you'd want to parse those, like a large data set to compare apples to apples, right? And one thing we talked about in our breakout group was the fact that Vancouver was going to start requiring whole building LCAs, I think, next year, right? And if you have that data, that could be something that, you know, you'd be able to, instead of having such a granular, like this is specific for, you know, all 6 stories and less, you would have more, be able to parse down more. That's what SC 2050 is doing. I mean, for structural, we're taking system base size, some more criteria that you can compare apples to apples.
And so like what in the reported data, are you saying like we should use the top line number of like what's the kilogram of CO2 per meter squared or something from like all the submissions, or are you saying like we need to be more granular? Or yeah, actually, can you expand a bit more, like on the whole building base or like on individual elements?
No, so it's for a system. So because our buildings are so variable, right? Like every site's different, every system, you know, the shape, it impacts a lot. So if you can compare like to like when you have a larger data set, and so you say, you know, archetype, architectural, like base size, and maybe you're in a certain region, so certain materials are more available. You'd be able to compare those for that region. So it gives you more of a functional equivalence is kind of the fancy word.
Yeah, perfect. Thank you. Roberto?
I'm usually afraid of granularity in some situations. Like I'm afraid that, you know, like when we were just talking about column spacing, you know, you revise the structure to increase the column spacing. You maybe you're using like post-tension slabs, and all of a sudden you got bigger column spacing. My thought was for an archetype, going back to the assumptions that you had on your screen, Anthony. I thought, would proportionality be a decent basis for an archetype? As in, what I mean by that is weight or mass proportionality. So as an example, rather than specifying window to wall ratio, rather than specifying type of structure, you know, just basically take a set of data on 3 or buildings under 7 stories, let's say 1 to 6 stories, and you say out of 100% of the material volume or weight, I'm not sure what the right one would be, 2018 is, or 20, whatever your year would be, you'd say 50% of that is concrete, 25% of that is steel, and 25% is wood. I'm just making up numbers here.
Yeah.
And you sort of, your baseline would basically be based on proportionality. So it doesn't matter. So then you compare your building against that weight or volume proportionality. And then you say, this is based on this proportionality, here's my global warming potential for my building. And then your comparison would be that, you know, the 2018 proportionalities. It's less granular. I don't know if it would work, but it's maybe a rougher, simpler starting point for this, for applying this. I don't know.
Yeah, no, that's an interesting idea. Thanks for sharing that. It's a tough one. It is tough. No, we're just trying to get as many ideas on the board as possible because we're not. I don't feel like there's a definitive answer on this.
Yeah.
Sarah?
This is going in a little bit of a different direction, but I'm wondering if you've considered how the baseline may change based on what phase of design is completed when the LCA practitioner has been engaged. So, for example, if the consultant or the LCA practitioner is following the changes in design from pre-design, it's going to be really easy to say, oh, we designed this concrete to be much less than what was originally considered. But if the practitioner is engaged after the design is finished, it's really tough to compare to a baseline besides just industry average values, which aren't really comprehensive right now. So I guess my question is, do you think there will be requirements for when the LCA process needs to start and when these decisions need to be tracked?
I think that's a good point. I mean, I think, well, at least with where the City of Vancouver, especially under the rezoning aspect, like currently it needs to be done at the rezoning stage. So that's kind of more schematic design. So you already need to do that at the earlier stage. And I would imagine that might potentially get trickled through even in the later requirements potentially. But I think you raise a good point about like just thinking through the different stages of designs, how this baseline works at each stage. You know, like for example, in the schematic design stage, maybe you don't have foundation data. Like what do you do there? Should you just pick up a number there? Should you not? Like there's all these like nuances to it. And as you get more detailed in design, oftentimes the number keeps going up because there's a lot more materials that you haven't factored in the schematic phase. And so I think that's one of the challenges with like kind of more of these absolute metrics. Yeah, but I think that's a good point.
Thanks.
Yeah. Patrick, did you have something to share? Or I saw a comment. Oh, I think you were referring to Roberto's comment.
Yeah.
Yeah. Yeah. Okay. Let's see. Yuri, your hand's been up for a while, but I don't know if you actually you just haven't lowered it, or
No, I didn't. I just because when we started talking about through this conversation, we started talking about different data from different LCA tools, and I just wanted to bring it to the community here because that's what I've been seeing, and I just kind of I want to make sure that I'm not making a mistake, but I feels like there's something that we need to deal with really quickly. So we know how we discuss a lot the different softwares, tools, calculating the embodied carbon differently, and that's an issue. And I really want to jump into this issue quickly. So there are two components when we're using different software tools. The first component is actual volumes of materials that we input. And the second part is what kind of, let's call it the factors, embodied carbon factors we apply to these materials. And so obviously what kind of factors, what kind of data is a challenge. And it's hard for us to deal with that. It's the people who do this research work, we're waiting for it to happen for a lot of materials. However, the volume part is something that we can own, and we need to make sure that is right when we compare three different softwares. Obviously, if you use a Revit model for one tool and it actually calculates your volumes versus you do Athena option where you do assembly and you can't find the assembly that you actually have, surely you're going to get a different feedback. So why are we even comparing those results? My point is, before we start worrying about different data, let's make sure when we do a study that volumes of materials are the same. And I think this will bring those results quite closer to each other.
Great point on that front. And I think there's actually, Patrick, I don't know if you want to share anything about the Athena approach, because I think they're talking more about the material use intensity.
Sorry, and last thing, Athena, you can throw in, you can use, if you have your data, if you do your volumes, you can use it as a tool just by introducing the materials, weights or cubic meters, and it beautifully calculates it cannot give you the perfect assembly, but if you give it exact material, it will do pretty good job.
Yeah, that's fair. Point noted.
I don't have anything, I guess, genius to contribute to that. But just to your point, Anthony, if there's a standard that anyone could reference around takeoffs, like if there's a ASTM standard or an ISO standard on takeoffs and how to do them for your specific building, something like that would be amazing to be able to reference. I don't know if it exists though.
Yeah, I think that's a really good point. It's something that we've grappled with a lot as well. Is just ensuring that the quality of our takeoffs are good and that we're getting the right quantities. I think I had a brief conversation with Matt Bowick earlier today, previously from Athena. Now he's with the National Research Council, and he's actually developing a whole building LCA guidelines as well. That is not published yet, but it's in development. And I think, and Athena has been proposing this approach for a while as well, as actually having a benchmarking program that's based on material use intensity. So ideally, if we're not just collecting the end results on LCA numbers or GWP numbers, but we actually also collect material use intensity. So how much concrete per meter squared or how much wood or whatever that. And with those material volumes, we can actually do more with that. And then after the fact, potentially think about how that connects with the different software tools to generate the end kind of GWP results. So I think there's definitely some potential in that approach. And potentially that could be done more at a granular level too. So maybe you don't take the material quantities for the whole building, maybe you just take it for the structural frame. So maybe if you actually have some good average sample set of many different structural frames for a given archetype, and you actually have the material quantities at that level, maybe we can then use that to swap out the different structural frame options, and then maybe everything else you keep the same. There's many different approaches to this, but I think that's something that is being thought about right now.
Sorry, does that exist, Anthony? Do they have something started on that, or?
I don't know if it exists or if it's in development, or I think I've seen the proposal before. Athena has published some stuff on this front, and I think there may potentially be work on this. Yeah.
Yeah, it's a hot topic for the SC 2050 folks as well, because it's something that you want to include both to validate the LCAs and the final results, but people can be hesitant to give those numbers because there's concern about cross competition that I say. My company. Yeah, right.
Interesting. I didn't know.
Yeah, for structural engineers, it's there's not much more to compete on than I build my steel building lighter than you. But just to tag on one thing to Yuri's point, which I really appreciated, was there's variability even within those calculations. So say you have a steel frame, you can do the takeoff, but there's a number of things that I think that aren't standardized, and there's potential to standardize those. Like, what is the waste factor? What are you allowing for connections? And I was just going to add that maybe I think contractors would probably have a good perspective to contribute on that. And it would just be good to have some leadership within the AEC industry to keep people doing the same thing.
Totally. That's awesome. Matt?
Yeah, I just wanted to respond to what Yuri and Elizabeth were talking about as far as tool choice goes, and the differences that come in as a result of just simply the tool that you choose, even if you have exactly the same takeoffs. I'm not, depending on how the city structures this, I'm not sure whether that is actually even going to be relevant or not. Like if you do your baseline calculations and your actual calculations on exactly the same tool with exactly the same background data, the same versions of everything, then you're comparing apples to apples as far as the tool goes.
Mm-hmm. Yeah, I do think like that approach probably eliminates a lot of the variability, but I think especially if you get into a point where you're comparing different structural frames, I think that in particular, I think is a more challenging issue on how to address that, like different materials like steel frame versus concrete frame or whatever, because then you don't necessarily have that fully modeled. But yeah, thanks for sharing that. Jeremy?
Yeah, so my comment, I threw it in the chat, but one of the things that I think is really interesting that is maybe outside of the design stage permitting piece, but is more or maybe outside the regulatory piece, but kind of within the design piece is, okay, so how do we move past the baseline, which is just structure and enclosure? And like, I thought Eric had a really good point. I just triggered a thought because I work on lead projects. Like one of the things that I know the tools that exist today are pretty rough on their construction, like their A4 emissions estimates. But we, through, for the foreseeable future, all office buildings in Vancouver will be LEED, or if they're not, passive house. And so we'll have waste hall data. So at post-occupancy, we have to do an update anyway. If we as an industry are trying to figure out where those emissions are coming from and trying to improve on that granularity, that's maybe a source. Just a thought.
Is it on the waste side of things? I'm not quite sure.
On the waste tracking, yeah. So some of the emissions that
you're talking about construction waste.
Construction waste. Construction waste, yes.
Okay, got it. Yeah.
But also, end of life disposal.
Yes, yeah. If you're like rezoning a building or something, or you're demolishing a building, and yeah, okay, I get that. Yeah. Yeah, good point. Yeah, maybe there's some kind of synergies with other programs or initiatives. Yuri?
Do I have my hand up? Sorry. This time you're right. I
just say something brilliant and we'll be fine. All right. Anyone else?
I just had a question for Jeremy on that point. Do you mean that you'd get better data regarding waste and how to take it into account? Like, do you mean you'd get better data that could feed into the tools that could update the outcomes? Or do you mean like you would actually change your inputs based on better data, or you change how baselines are defined based on better data?
I kind of think it's outside the baseline, because within the tool, as I understand it, both in OneClick and in Athena, you don't really get to define what's going on in A4. Either it's excluded or it's 1% of the A1 value or something. I can't remember.
Yeah.
And it's a fine assumption, especially when you're comparing apples to apples. But if we're trying to be more holistic and if we're looking for more work to do,
always.
No, but if we're looking to be better, I mean, that's one data source that's both out there, and maybe not so much for trying to estimate A4, but also for C, because for buildings that are being torn down, we on the lead team will get the waste tickets. We'll be collecting them. So
I have actually looked at the waste data, but I think the level of granularity is very coarse. And so it's going to be very hard to then figure out, like, for example, you have a metals category. What type of metals and how do you disaggregate that? Like that can be potentially challenging. But I take your point. I think there's potential for looking at how we could use that information. Perfect. Well, anything that's left unsaid, anything that you think like we should consider, or any other parting thoughts around baseline definition?
I haven't thought this through very much, but does it have to be either or? Like, does it need to be sort of an absolute per square foot, per square meter, or compared to a baseline? Or could it be a combination of both, sort of to prevent against gaming the system? You know, maybe if it was only per square meter, you could, you know, not include certain things, or try to, I don't know, mess with the sort of floor area versus more intensive materials factor, lower your ceilings or whatever. I don't know, but maybe it doesn't have to be either or.
Yeah,
you can guarantee that somebody's going to find a way to game the system. So part of it is going to be,
if we collectively come up with the best approach.
Yeah, how, as far as the policy approach goes, how is that going to be exploited to game it, and see if that can be addressed as well during the policy development.
Yeah, I think that's the yeah, good point on.
Yeah, and I feel like Anthony, you raised some kind of like counter, you know, a devil's advocate points against the absolute performance values, but I kind of feel that there's, you know, both sides. Whichever one you go with, both of them need guidelines, and both of them are open to kind of interpretation and issues. And I think that from my point of view, I don't think that there's more issues with the absolute performance numbers than there are with the baseline comparative numbers. I think that it's different, and potentially I still don't feel like the way to go.
Yeah, sorry, I didn't mean to pick on one or the other. You're right.
No, I think it's a valid point. Like, both of them would absolutely still need guidelines of, you know, what is included and what's not, in the same way that the base, you know, how do we set a baseline award is kind of, you know, how do we set that? But yeah.
Yeah, no, that's a good point. And actually, like the International Living Futures Institute, I think it's either their zero carbon certification or the energy pedal within the Living Futures or Living Building Challenge. One of them actually had both a percentage reduction. I think it was like a 10% reduction plus a 500 kilogram of CO2 per meter square cap. So that's a potential of like where I've seen it's kind of a bit of both. Like they have a cap for what the max is, and also you still need to do a percentage.
Yeah. So and I think one of the big positives of that is it can help with the people's knowledge and understanding of the language. Like I think as EUI has come in, people have now kind of got their like, okay, now it has some numbers. Whereas when you're just talking percentage, it's very hard to kind of like look kind of comparatively comparing buildings. You know, that's why people kind of started to say like, oh, this one's LEED Gold as a standard, even though that kind of means nothing. You can get, you know, between 2 and 20 points, you know, and people just fell to that because there wasn't this kind of like numbers. And now people are like, oh, that's a 250 EUI building. Like, oh, okay, like that kind of like has a little bit of sense of something. I think is lacking, certainly in the embodied carbon, when we're trying to talk about it with a greater audience.
Totally. Yeah, that's point taken. Sarah?
I was wondering if there are differing opinions on either standardizing the repairability and replacement cycles for baseline buildings, or keeping them the same as the corresponding materials in the proposed building. Like, for example, if you're saying that you're doing a specific cladding system in the baseline building, should all the cladding systems be on a replacement cycle of 20 or 30 years, or should each individual materials match up?
I think that's a very good point. And actually, I think the different software tools have different assumptions around replacement cycles, and also whether or not you can override those assumptions. And I've been actually searching for good data on this. So if anybody actually knows of like good sources of data for like what is kind of typical lifespans or different, you know, there's many different definitions for those lifespans, but I think that could definitely be relevant. Luke and then Jeremy.
I think Jeremy you had your hand up before me if you want to.
Oh, okay, sorry, Jeremy.
I changed I put my hand down and then put it back up. So thanks, Luke. Yeah, one of my, just to maybe change the tack, one of the things that I was also thinking about for baselines is, would we be assuming 100% new bed build? I mean, I assume that we are. And for projects that are doing reuse, would you be looking at, like, how would you capture that as part of your proposed? Has that been something that just as the group has thought about? Do you just not model those emissions? Or if it's like being reused from another site?
Yeah, I think that's a good point. I mean, I think generally the reuse portions can get a free pass on the A1 to A3 or whatever. So, but yeah, I think you're asking about the baseline. Do you then model that kind of reuse portion, that square footage, as new construction?
Yes, yes, exactly.
Yeah, I would potentially think so, but I don't know. Maybe Patrick has different ideas, or other people have different ideas. But yeah. Who's next? Oh yeah, Luke then.
So yeah, I was actually going to tack on to something Sarah said about the sort of material cycles, and something I think is also overlooked in places like Vancouver and Los Angeles that are high seismic region is the resilience side of things, and supplying a building that is either low damage or, you know, doesn't have to be torn down after a seismic event. And how do you capture that? Because I mean, it's more complicated, right? So it's sort of just kind of neglected at this point. But in the case of a significant seismic event, the way we currently design buildings, a large portion of them would need to be torn down or demolished. And even smaller seismic events, you have a lot of damage as far as like non-structural partitions and facade, things that have heavy embodied carbon impact.
Yeah, that's actually, I think one of our future events, probably in like Q3 or Q4, we're going to do an event focused on seismic and embodied carbon. And there's some people that have done some analysis on this, on like, you know, adding additional seismic requirements so that the building kind of withstands greater, it's a probability game at that point, right? But they're trying to use those seismic metrics and map that to embodied carbon and see what the implications are. So we will actually have an event on that. Yeah, in a few months.
That's awesome. I'd love to see that research.
Yeah, there's some interesting research on that. Demuth? I'm not sure if I'm pronouncing your name right. Demuth, is it? Yeah, okay, yeah.
Yeah, just to comment on the durability and service life of different materials. I think it's important to capture that, but that benefit. So I don't think it should be reflected both in the baseline and in the design. I think any benefit you have from service life in the design should be captured.
No, definitely. I think that would be the ideal approach, and part of it is just figuring out, like, can we do that on the, like, how do we model that, and also like what ability we have in the different software tools to do that. If I'm understanding correctly, I'm not sure if I got that. Okay, thanks. Yuri?
Yeah, I just want to, it's a really good point that Luke made in terms of seismic, that like different buildings. So yeah, that's very complicated. But also when we compare, just keep in mind when we compare buildings in Vancouver, and let's say there's an absolute baseline, we compare building in Vancouver versus building in Toronto and that 16-story concrete tower, we're going to see a big difference just because of the lateral system. We're going to have a lot of concrete in it. So we just need to be aware of this local, even within the British Columbia, there are different regions for that seismic portion of the structure will affect overall the embodied carbon by, I don't know, 10%, let's say. That could happen.
So that comes back to the same discussion as the parking is parking included or not? You look at a building in Surrey versus a building in downtown Vancouver, they have very different parking needs, for example, even though the seismic is the same, as the seismic demands would be the same.
Yeah.
So the baseline.
Sorry, and it's
the baseline
needs for steel buildings and wood buildings too.
Yeah. So the baseline needs to be in the context of the specific location.
Yeah. Yeah, I think that's, good points to keep in mind. Any other parting thoughts? I know we're kind of a little at time now, but this was an amazing discussion. All right. I think that's
can't
it.
figure out how to raise my hand.
Oh yeah, no worries. Yeah. Please speak up. That's it. Yeah.
I kind of feel like, the web diagram that is in some of the early LCA books where there are different benefits and losses based on a given decision. So you might have like higher eutrophication impacts and lower GWP.
Right. Yeah.
It would be helpful to have a similar way of thinking about something like circularity. Can I reuse my building? If I have to build site, is this the best site to build on, or what is the seismic zone and how does it impact the mass of the structure? And then things like the A1 to A3 impacts could be reduced through reducing quantities or EPDs, but it's like there's a different approach to each of these things. And then sequestration, where does that live? And I feel like we tend to want to simplify this into one number. And to me, it would help if there were different metrics for each bucket of impacts. And then we do need to understand the relationship to one another. A lower carbon envelope might mean a higher mechanical cost, but they're not, you can't really just say this is my baseline and then be as effective as possible. So I think as this movement builds and it becomes more of a field, it would be helpful to be able to break it out. And then like end of life is totally almost its own thing that requires a contract with the owner, and it's related to the material that you choose, but nobody knows what's actually going to happen. And then design for disassembly is required, etc. So I
think there's so many different strategies and so many different elements to this. So it's like, it's kind of a bit of a blank canvas right now. And a lot of us are trying to like fill in as much of that territory as possible and like try to figure out what about this and how do they compare and what's the trade-offs there. And I think that's going to be the work that we're all kind of engaged in as we kind of explore this deeper. Yeah, that's a really good point. Any other final comments?
Yeah, good luck, Patrick.
Yeah, Patrick, we're just presenting you with the recording and this the Mentimeter stuff. And
Patrick, go.
Well, it's not my problem alone to solve. That's the only thing saving me is that I'm, we're all working as a community on the problem, and it's a challenge that everyone is solving, and that everyone is working on their desks and in different ways and different aspects, and only by everyone kind of taking their part of the pie can we get anywhere near where we all need to go. So good luck, everybody.
Oh, we're waiting for the answer, Patrick. No. Awesome. Well, thank you so much, everyone. This was an amazing discussion. And yeah, we will do more events like this in the future as well, that's more interactive discussion based. So this was amazing. Thank you so much for, and also staying an extra half hour or a bit more than a half hour. We'll see you at the next event. Thank you. Have a great evening.
Bye.
Thanks, everyone.